All right, so I'm actually going to end up explaining method of sections first, because basically if you're not doing method of sections, that's when you do method of joints. So in terms of understanding when to do what, basically that's how I go through it. If method of sections doesn't work, then I use method of joints. So this is a truss. I can tell because it looks like a bridge. Usually there's some supports here. There's a pin on this side and a roller on the other side. We'll just pretend that they're touching each other right here. That's fine. All of my dimensions are labeled. I have some loads at some joints. Yeah. So basically, the question that we're going to answer is to find the forces in JK, JM, and LM. So basically right here, and this diagonal. So that's important to understand because these are related somehow. And I will get through that in a second. So in terms of steps to approaching a method of sections problem, you want to draw your free body diagram. So yes, you do generally want to redraw the truss structure, right? So that would include the support reactions here and here. So that would be a X and a Y. And then here would just be BY. And then on my free body diagram, I would just get rid of the reactions or the supports themselves. So the roller and the pin are no longer there. And then I'm left with a bunch of forces, right? So after I've drawn my free body diagram, obviously it'll probably be a little bit prettier than this. I want to kind of look at what the truss structure actually is. So at this point, we've done step one. And one of the ways that you can evaluate a truss structure is by finding zero force members. And that'll really help you to simplify the problem for the most part, but sometimes it allows you to make a cut that you wouldn't be able to normally make without first finding those zero force members. So looking at this truss, remember the criteria for something to be a zero force member is you're looking at a joint, three members meet at that joint, two are collinear, one's not. There's no loads. The non-collinear one is a zero force member. So there's only one member in this bridge that fits that criteria, and that is right here. So that one's a zero force member. So in the future, when I draw this, I can draw it without this member. So that kind of simplifies it just a little bit. In other cases, it'll simplify it a lot more. Here, not as much. So going into step number 3, I've simplified it as much as I can. Now I have to identify which members the question is asking for. So in this case, it's asking for these 3, like the orange ones that I've outlined. And there's still a joint right here. That's important to remember. So these are still joints. And if you notice down here, I wrote that they'll be related somehow. So right here, it says they'll be related. And by that, I mean that they'll be somehow close enough where you can cut through all of them at one time. So basically here, I can cut straight down this way and expose all of the internal forces in all 3 of those members at the same time with one cut. So that kind of goes into step 4, where I want to cut the truss into 2 separate pieces. So as I just did, this cut right here ends up separating. I can separate from here over, right? So there's 2 separate pieces of the bridge at this point. So looking forward, one thing you have to be careful of when you're finding where you want to cut this bridge is you have to only expose 3 members that are not zero force members. So you can cut through a zero force member, that's totally fine because you know it's 0. But I can't cut, for example, I couldn't cut through, oh yes, I could. I couldn't cut through, let me find one. Anywhere where I would be cutting through 4. So basically I couldn't cut here because I'd be exposing this, 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 and this, right? So that wouldn't work because now I'm exposing 4 zero force members, or non-zero force members. So that's 4 unknowns that I would have, and I only have 3 equations. So this is my cut, and it only exposes 3. So here's 1, here's 2, here's 3. Boom. So far we're good. The next step is to choose one side that you want to solve. So usually I choose the side that has the fewer forces on it. I choose the side that's like shorter, looks simpler, something like that. You don't really have to choose one over the other. It's kind of just whichever one you choose. Looking at this truss though, I still haven't found BY and AX and AY. So the important part to realize there is that if I'm only looking at, say, the right side of the truss, so like if I'm looking at this side, I only care about what BY is. So I can find that in one step by taking the moment about AY. And then these get canceled out and I'm left with BY, which is just a simple solve that problem, like solve that equilibrium problem. So BY I can find using only the external forces. So at this point, you don't care what the internal forces are. You would just use like this, 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 and that. And then you would use these perpendicular distances up here. And then you find BY in one step. So then by that point, you found all of the external reactions at that side by finding BY. So I'm going to erase this part, this entire side of the bridge, because I'm only going to look at this side of the cut. So from there forward, I'm only looking at just a piece of it, which makes sense because I've cut it. So this is what I'm looking at. Moving on to the next step, you want to redraw a smaller free body diagram because obviously in like on an exam or a quiz, you can't just erase half of a bridge. So basically you would redraw it with the forces here, here, and here. That was JK, JM, and LM. Okay, so now I've redrawn my free body diagram. Basically, all you have to include is the stuff on the side of the bridge that you're looking at. So technically, I wouldn't even have to include this stuff. So that's my new free body diagram. Moving on, solve using equilibrium equations. So I know I have 3 unknowns. At this point, BY is a known, so I'm just going to say it's 200 newtons. So now BY is a value that we know. So I have 3 unknowns, 3 equilibrium equations to solve it. If I have to use all 3, I personally usually start with the moment equation because I can take the moment about a common point between these 2 and solve for the 3rd unknown one. So if you look at it, there's a common point right here at J because both of these forces go to J. There's also a common point at M because both of these forces go to M. So I could take the moment about J or M. I'm going to start with the moment about J, just because that's the one I saw first. You could do either. So taking the moment about J, this cancels, this cancels. I have LM. So LM, oh, I'm going to look at it clockwise. That's positive. So LM, and that is times the perpendicular distance of 6, which was there, but I erased it. So LM times 6. And if I pin it at J and pull along LM, that's positive because it's pulling it clockwise, right? It's pulling it like that. So then I move forward. My next one is this 100 newtons. So I have 100 newtons times, I have 8 meters away from J. So it's 100 times 8. And if I pin it at J, pull down at 100, it's still swinging it this way. So that means that it is also a plus. Finally, I look at this 200 newtons, and that is 12 meters away. So 200 times 12, if I pin it at J, push it up here, now it's spinning it this way. So that's going to be minus 200 times 12. And then I can solve this one for LM. All right, my next step, now I know LM, so now I have two unknowns and I have two equations left. So if I'm going to look at the forces in the Y direction, I have positive 200 over here. So I have 200 minus 100. And then I have just one component of JM, right? And it's going up, so it's JM times the ratio of it. So it's looking at this ratio, it's a 2, 3 triangle. So it's 2, 3 square root of 4, 9, square root of 13. So if I'm looking just for the Y component, it would be 3 over root 13. And then I can solve that one for JM, and now I know JM. Solve for JM. All right, then my last one, now I know LM and JM. So now I can do the sum of the forces in the X direction equals 0. JK is going to the left, so that's negative. LM is going to the left, so that's negative. The X component of JM is going to the left, so that's negative. And then I have to do times 2 over root 13 because there's only a chunk of it going in the X direction. And then none of the external forces are going in the X direction. So I know this already, and I know this already. Oh wait, no. I know these two already. So then I can solve this for JK. And now I have found JK, JM, and LM. And the important thing to remember is that for all of these, you have to have a magnitude, unit, and direction. So my magnitude would just be the number that I find for these values. My units are going to be newtons in this case because they're all forces. And my direction for, let's see, JK and LM will just be an arrow to the left or right, depending on whether the number came out positive or negative. If it came out as a positive answer, I just assume that my drawn direction is correct. If it came out negative, then I would switch the arrow. For JM, it's at that diagonal, right? So then my direction would end up being, my direction would end up being this, where that's 2, 3, or this, where that's 2, 3. So a lot of people missed points on the first exam because they didn't include this slope triangle. And that slope triangle is important because you can't just draw that diagonal arrow and call it a day. So magnitude, units, direction are all you need for this. And then that's your answer. So again, these are the steps that you go through every single time to start and solve these problems. So now in the next video, I'm going to go over method of joints because you only do method of joints if you can't cut it and expose only 3. So here we could cut it, expose 3, and solve. There's going to be cases where you can't do that, or they're asking you for too many, or they would be asking you for this, like all of them. So if they're asking you for all of them, it makes more sense to just do method of joints because you have to hop anyway. So we'll go over that in the next video.